We're going to take another look at number 11. These were complex fractions. But notice with this division bar right there, we could set it up like so, which is an example we had done earlier. This divided by this. We're going to change the division sign to multiplication, factor each of these, flip this over, factor each of these, and see where you could possibly cancel things out. Now here we see this will cancel with this. This will cancel with this. And that's about the size of it. So you're going to have this and this on top, and this on the bottom. Now you could foil this. You could put a squared there, or just leave it like this. That would be good. And again, we had passed that one up because others that are similar are done a little different way. But this can be done this way. We're now going to go into division. And here there are a few techniques to keep in mind. So we're asked to divide all of this by this. Now another way to set this up is take this and put that under each term. So in a sense you're asked to divide a trinomial by a monomial. And this is the technique. And then you just carry out your division. So this is going to be, take a 3 out of each one, 5 halves, and you're left with an A on the bottom here. The B's cancel out completely. And the second term is plus 6 will go in 18 3 times. And let's see here. The A's will cancel out completely. I'm on the wrong one here. Let's do this one first. The A's cancel out completely. There is a B left on the bottom there, and you have a C squared on top. And then this last one's a negative 6, and these will cancel out completely, and you're just left with a C. So there's the answer to number 16. Now, number 17, they want you to set this up as a long division. And again, we're just reviewing what you had in class. And we say y goes into there how many times? Well, y times. So this times this gives you y squared. This times this gives you a negative 2y. And then the rule is we change the signs, and then we add. So this cancels out. Here we end up with a negative y minus 25. Y goes into there, a negative 1 times. And then y times negative 1 is a negative y. A negative 2 times a negative 1 is a positive 2. And the rule is you change the signs and add. So these cancel out and you end up with a remainder of negative 27. And I just want to check that. And that is correct. And then you write your final answer as this, and then you put this over y minus 2. So the remainder would go up here, depending how you're putting it into your math lab program. Okay, let's go on to the next one, because this one's a little more complicated. Let me set it up for you. So the key here is we have our divisor that we set up like so, and then we divide it into this. Now notice there's x to the fourth. There is no x to the third. So we have to put in there a space holder, which is 0 x to the third. It doesn't have any value. It's only a 0, but it occupies that space. So we want to go 6x to the fourth divided by x to the second goes 6x to the second. Now when I multiply x squared times 6x squared, I get 6x to the fourth. When I multiply 3 times this, I get a plus 3, well, 3 times that would be 18. So 3 times 6x squared is a positive 18x squared. Okay, we have it all set up. Now what we do is we change our signs. This becomes a negative, this becomes a negative, and there's nothing there right now. So I bring this down. This is going to be 0, and this will become a negative 20x squared plus 3x. And I don't know how much of this we're going to bring down here, but let's try it out. Now, x squared goes into a negative 20x squared a negative 20 times. So x squared times this is a negative 20x squared. I guess we didn't need this time. And now 3 times a negative 20 is going to be a negative 60. 3 times a negative 20. Okay, we're not using that right now either. Okay, so our rule is change the signs and we add. So this cancels out. We're left then with a 3x plus 15. And I could factor out a 3 there, but that's going to be over our divisor here, which is x squared plus 3. You could leave it this way or write it in its factored form. In the answer key, they left it this way. This over that. This plus this remainder. This would be okay too, but not here. Okay. Now in number 19, we're asked to do this by synthetic division, which hopefully you've had a little experience with. This is x minus c. So to set it up, we take the opposite of what c is in terms of its sign. So here it's a positive 2, so we're going to use a negative 2. And then we put an upside down division sign here. And we just take the numerical coefficients of our numbers. So this is a 1 plus 6 plus 4 plus 1. Some textbooks don't put the pluses there, but it's okay to do that. Now the rule is you move your first number down, and that just becomes a 1 there. And now you start the process. Negative 2 times 1 is a negative 2. And here we just add them up. Negative 2 times 4 is a negative 8. Just add them up. Negative 2 times negative 4 is a positive 8. Just add them up. So we have everything in place now. Now the rule for synthetic division is once you get your answer down here, you have to convert it back into algebraic form. And the rule is it's one less power than what you started with. You started with 3. So this then becomes x to the second, this first one here. One less power. This will become an x. This is the whole number, and this is your remainder. And you use what you originally had. Synthetic division for number 19. Now here, this one is a function problem where they're asking us that this is the function they want us to use to synthetic division to find when our divisor, remember it was x minus c, is going to be a 3. So we put the 3 there for synthetic division. We take the coefficients of each of our terms, put them there. We bring the 3 down, then go 3 times 3 is 9. 9 plus 1 is 10. 3 times 10 is 30. Subtract 7 is 23. 3 times 23 is 69. Subtract 1, we get 68. 3 times 68 is 204. Add 6, we get 210. So this is called the remainder theorem, that when they give you a value to put here, that's what you're going to put there in synthetic division. You're going to convert this to the synthetic division form by using the coefficients and following the pattern. What do you end up with? What is your remainder? And that is the answer to number 20. Now for this next one, they want us to solve for this particular variable right here. So we can kind of highlight that letter there, V2. So what we're doing, first thing I'm going to do is get rid of this fraction 2 by multiplying both sides by 2. Here the 2's cancel out, and I get 2s. Then I'm going to divide both sides by t. Here the t's cancel out, and I have this then equals that. Now all I have to do is transpose this to the other side, where on this side it will become a negative. So I transferred it from this side where it was positive to the other side now, where it's negative. So v sub 2 equals 2s over t minus v sub 1. Okay, let's look at some of these others. Now I would suggest that you may want to go back and read this on your own, which is what we'll do for a number of these, but I've worked it out for you. Here are the product of the reciprocals of two consecutive even integers. Well, the first number is x, the second even integer, x plus 2. So what are the reciprocals of these numbers? Well, it will be 1 over this and 1 over that. And that's what I have here. So the product will be, you're going to multiply these two together, and it's going to equal 1/24. So when I multiplied this, I got this. And now I have two fractions that I'm going to cross multiply. So I get this equals 24. But in order to solve it, I have to put it in standard form. So I transpose the 24 to this side, and then I have to factor it. I factored it, equal each of the factors to 0. So here I get x equals 4. Here I get x equals negative 6. So there are actually two possible set of solutions for this. One set would be the answer is 4 and 6 would be the two consecutive integers. Or the other one is negative 6 and a negative 4. These are two consecutive integers as well. So two sets of answers. They're giving you the first member of each set right there. Now in some cases down the line, we had mentioned in class that if you get a negative and you're measuring something, you would reject the negative answer as not possible, because the length of something is never a negative unit long. All right, let's go on and look at this next one here. It says Kendall can paint a room in 6 hours. So his rate's going to be 1/6. Kevin can paint the same room in 4 hours. So his rate is 1/4. That's how much they can get done in an hour. How long will it take them to paint the room together? Well, this is one of our work formulas, which looks like so. So here we're going to multiply every term by, and I can do it this way too, 6 times 4 times t. So here, when I multiply this term by this, the 6's cancel out, and I get 4t. Here the 4's cancel out, and I get 6t. Here the t cancels out, and I get 24. So I get 10t equals 24, and t then equals, divide both sides by 10, I get 12 fifths when I reduce it. 24 over 10 is 12/5, which is 2 2/5 hours. That's how long it will take for them to paint that room together. Okay, let's look at the next one. Let's set this one up. Now, for number 24, I had to work a little bit of time on this, but so I just didn't pull out a formula from my pocket, and all of a sudden I had to reread it again. But here's the strategy I used. We're talking about a car traveling 175 miles at a certain speed. So this is distance equals rate times time. Now what we don't know about in this formula is time. So if we solve for the letter t, time, we get time equals distance divided by rate. So we know a little bit about that. So here's the distance, and this is the rate. So this is going to be slower, in a sense, or less time, because here, if they travel at 20 miles an hour faster, it's 1 hour less over here. So what we have to do is, to make this an equation, we have to add the hour to this side. So this amount of time equals this amount of time. Here, because it's faster, it's going to be less time. So to make it an equation, we add it there. Now, what we do next is we're going to multiply each term by the lowest common denominator, which is r times r plus 20. So here the r's cancel out, and we get 175r plus 3,500. And I worked this out already, so. Now here we're going to cancel this with this, and we end up with 175r. And then we have to multiply this by 1, which we're going to just distribute here, r squared plus 20r. So timesing 1 by this, I get r squared plus 20r. Now, these just cancel out. I want to keep everything positive, so I'm going to put a 0 on this side, transpose it to this side, so I get 0 equals r squared plus 20r minus now 3,500. Now, this was the tricky part, and hopefully you have a skill to do it. We now have to factor this, r. And when you're thinking 35 and 2, what are factors of 35 that have a difference of 2? And it's 5 and 7. So this will be a 70, and this is going to be a 50, because we have to add our zeros. So we need a negative in the middle, positive in the middle. So this will be a positive 70, and that's that. So our answers are going to be from this one, r is going to equal 50. And for this one, r will equal a negative 70. Now, you don't go negative miles per hour, so that one's out. Our answer is 50, and that checks. Okay, let's go on to number 25. Now, for this one, we're setting up a proportion, 3½ cups of flour. So this is flour to water, 1¼ cups of water. Now, how many cups of water if we have 6 cups of flour? So there's our proportion, and we have to fiddle with it. So it's going to be, let's just change this now to 7/2 times x. Here, I guess we can just put an x there. This is 7/2 times x equals 20. Let's see, this becomes, let me change that, not thinking something else here. 6 times this is going to be 5/4. So this is what I was thinking of. This is going to be 7/2 x equals 30/4. Now, we can do cross multiplication here. This will be 7x times 4 is 28x equals 60, and x will equal 60 divided by 28. So this will be 30, and this will be 14, and this will be 15/7. So it looks like 7 goes into 15 twice, 2 1/7 cups. Let's see if I got that right. I did. So I should have probably worked it out and checked my answer, but that's how you do it. Set it up as a proportion. Convert these mixed numbers to improper fractions. Do your cross multiplication and solve it. That was a good one. Okay. Okay, number 26 is also a proportion, but it's a direct variation. Now you may recall for direct variation we use the formula y equals kx, where we have to solve for what k is. What is our constant of variation? Well, they're saying for an 8th grader, they get 856, and they're an 8th grader. So we get here K equals 107. So if there's a 5th grader there, it's going to be Y equals 1.07 times 5. They're a 5th grader. And that's going to give us 535. So weekly allowance for a 5th grader. Again, I don't have any small children, so I don't know too much about all this stuff, but that's sort of interesting, and that's the answer they have too there. So, okay, let's take a look at number 27 here. It says the time required to do a job varies inversely as the number of people working. Now the inverse relationship is y equals k over x. This is direct variation. This is inverse variation. So let's study this here. So we can convert this to the letters they're using there. Time is inversely proportional to the number of people doing the job. Well, if 4 people get the job done in 2 hours, what is K? Well, you just cross multiply here in a sense. K is 8. So if K is 8, how long will it take 12 people? Well, we just put the 12 there, reduce it to 2/3 hours, or another way of looking at it is 40 minutes. And that's what the book has. Let's go on to see what we have here. Well, to start number 28 off, we're going to multiply each term by the lowest common denominator, which is actually this and this, which makes that. So multiplying each term by this, keeping in mind that this is a negative here. So here this cancels out with that, so we're just left with 8x. Here the x cancels out, so we got to remember this is a negative 8x. And this is a negative 8 times a negative 12. So I saved a little time, I get this. Now, notice this all cancels out here, and it's just 96. Well, here these cancel out. Here these also cancel out as I subtract 96 from both sides. So I get 0 equals 0. Whenever we have a case like this, we have an identity that this is actually equal to that. And when that's the case, the solution set is all real numbers. That since this is an identity, the solution set is all real numbers. Any value we put for x, as long as it's the same, will be a solution to make this statement true. Why? Because this side is the exact same as this side. Okay, now the last few that they have here, this one is that complex fractions, which I don't think you covered. But let's take a look at our last example, and I will pause it and work it out. So it can be filled in 8 minutes, but can be drained in 6 minutes. How long will it take to empty a full tank if the water is left on? So here we're filling it up, here we're draining it. Notice we're draining it faster than we fill it up. And this is the amount of time. This is our time formula. So we're going to multiply everything by our common denominators. Here the 8 cancels out, 6 cancels out there, and the t cancels out. So we get t equals a negative 24. So it will take 24 minutes to drain the tank. Okay, because we're losing water. 24 minutes. All right, well, that'll wrap this up, and hopefully it's helpful. I know I haven't done some of these for a while, and it was helpful for me as a review.